Our next area of study is going to be galaxies. We've talked about stars, but galaxies are the bigger collections of things. So we talk about how stars live, how stars die, how they're classified, how the sun acts as a star. So now I want to talk about the bigger systems, the galaxies themselves. Our galaxy is called the Milky Way. It's called the Milky Way because in the ancient world they looked up the sky, and our galaxy from the inside looks like a faint milky sort of smear across the heavens. And so in fact the word galaxy itself comes from Galaxies, which is the Greek for milky. And so that's what the galaxy looks like, is sort of a milky smear out there. At one point, that was the only galaxy they knew was our galaxy, and so so that's where the term came from. Later, they started realizing there's other things like our own Milky Way out there, and that became the study of galaxies. So, as I said, the Milky Way. Literally, that's the name of it in Latin, the Via Lactea, the Milky Way. So our galaxy looks like a sort of a smear of milkiness in the sky. Now, of course, we realize now that's because it's a whole bunch of stars and nebulae and so forth. So the dark nebulae or the dust lanes can be sort of be seen in here as dark regions in there. Before they knew what that was, they called them rifts in the galaxy. So they would have the name of the Great Rift of Cygnus, for example. It's really not a rift, it's just a dark nebula or dust lanes blocking our view. So this is, of course, what the galaxy looks like up close in the telescope. Yeah. Okay, so the galaxies, our galaxy, a faint milky band across the sky. It's not uniform. It's thicker in one part of the sky than another part of the sky, and so that kind of led them to imagine there's a little bit asymmetric. So one of the things we discovered, though, was no matter what direction you look in the Milky Way, you saw about the same number of stars. And so if you look in other directions, you see fewer stars. And so this led astronomers some time back to imagine that it's sort of like a big disk or a big pancake with the Milky Way surrounding the sun being very close to the middle of that, because we saw roughly the same number of things in all different directions. So this is a picture showing the entire sky. The center right here is towards Sagittarius, and then the left-hand edge and the right-hand edge of the picture are wrapped around. So this is, imagine that wrapped around you, and then that's going, perpendicular. Okay, so so that's the Milky Way. The plane of our galaxy right here is lined up with that fat pancake around us. So William Herschel tried to map the galaxy, and he did it by counting how many dim stars he saw. He thought all stars were about the same brightness. He was wrong about that. But the dimmer the star, the farther away he thought it was, and he made it kind of a plot, and it showed something like this, with the Milky Way almost centered on the sun. Jacobus Kapteyn, J.C. Kapteyn, famous American astronomer, early part of the 20th century, actually late 19th century, early 20th century, mapped out the Milky Way as best he could, and he found it was about 3,000 parsecs, 3 kiloparsecs thick, and about 17,000 parsecs wide. 3 kiloparsecs, that's about 10,000 light years thick, and 17,000 parsecs is close to 45,000 light years wide. And his estimate was the sun was kind of close to the middle of it. So that's what most astronomers thought sort of towards the end of the 19th century, beginning of the 20th century. One sort of confounding issue, though. Charles Messier had found a lot of these little smudges in the sky. For example, this is number 31 on his list. Okay. The Great Nebula of Andromeda is what he called it, because of this fuzzy smudge right there. And so he had this big fuzzy smudge. Later astronomers with better telescopes saw that it had sort of a spiral shape to it, so it became known as the Great Spiral Nebula. And they started finding more and more of these things. They weren't really sure what they were. Some astronomers were of the opinion that these were objects that were swirls of gas coming together to make stars. Others, on the other hand, were thinking maybe there was something entirely different. Okay. Again, some of these things with better telescopes showed up to be spirals of various sorts. Well, there were a few led by a fellow by Vesto Slipher. Vesto Slipher was an American astronomer, worked at Lowell Observatory out in Arizona. And he was using a new technique to measure the spectrum of the galaxies. As he measured the spectrum of the galaxies, he noticed that almost all of these spiral nebulae type things were redshifted. Now, his idea was that meant that they were actually outside of our galaxy, being expelled from our galaxy or something. So he thought they were extragalactic or beyond our galaxy. So Vesto Slipher, he was the one that made these measurements, was a quite renowned astronomer. He became a very renowned astronomer, and in fact, director of the Lowell Observatory. And so this was his argument, that they were outside. Okay, so moving away from us. Harlow Shackley comes along, and Shackley, we talked about him. He was measuring distances to globular clusters and able to measure the distances using Cepheid variables in them. And he was the one who realized that we're not at the center of our galaxy. So he was measuring these things, and we know that there's a relationship between the period and the luminosity. And so if you know if you can measure the period, pulsation period, you can then find the luminosity. Y'all did one of the distant nature labs using it. And so by doing that, he expected to find that all these globular clusters were centered around us, the known universe. In fact, they thought the entire universe was just the Milky Way galaxy, the part that we could see. And so the entire universe there, but what he discovered was that the center of the clusters was actually out over here beyond where they thought the universe edge was. So that meant that our galaxy, which they thought was the whole universe, was vastly larger. So that became our understanding of the galaxy, that it's this very large sort of flat structure with a halo of these globular clusters around it. The center of the halo was in the general direction of Sagittarius, which is also where the galaxy tends to be a little bit wider. At least the Milky Way does, the visible part. So the center was about 8 kiloparsecs away. So just that's after modern measurements. Shapley's measurement was a little bit off, and he actually had a little further than that. But the modern measurement is that the center of the galaxy is about 8 kiloparsecs away. We still have about the same idea. The galaxy is about 3 kiloparsecs thick, and the middle part's thicker, and then bulge in the middle. So there's kind of a bulge in the middle of the galaxy, and then it's about 50 kiloparsecs wide. And then the globular clusters make a halo around the rest of the galaxy. Okay, so that halo is part of the galaxy, and we now realize the halo contains a lot more stuff in it than they originally thought. It does not have any of the dust and gas. The dust makes the dust lanes, the dark nebulae. The gas makes the bright regions in the sky. That's where the new stars are coming from. The halo has a lot of old stars, dimmer stars, because the O, B, and the A stars don't live long enough, but the smaller, dimmer stars are there. So the halo is mostly population 2 stars, and the total mass in the halo is really as much or even more than the mass in the spiral arms. So even though the spiral arms are the part that's bright and obvious, the halo is really a major part of the galaxy, even though it's like almost unseen. Still leaves a question about what are those spirally things that are out there. And there's a bunch of them that are out there. And so again, Vesto Slipher insisting that they were actually outside the galaxy. And other astronomers started going with what Slipher was thinking and thinking that they might actually be galaxies in their own right, similar to our own Milky Way. And this led up to the Curtis-Shackley debate. Aber Curtis, a famous astronomer, took Slipher's ideas that said the nebulae are in fact universes like our own Milky Way, island universes, he called them. And Shapley insisted, no, that the entire of everything was just the Milky Way and the things that orbit around it. So this was this big debate in 1920 at the American Astronomical Society meeting. Well, the debate was finally solved by Edwin Hubble. Edwin Hubble was just discharged from the Army, started work at Mount Wilson Observatory. On the outer edge of the Great Spiral Nebula in Andromeda, he discovered a Cepheid variable. By measuring the period of it, he was able to find the absolute magnitude, plug into this formula we've used so many times now, and was able to find the distance. Found that the spiral nebulae was a couple million light years away, about 2.5 million light years away. So to be as big as it is in the sky, it had to be at least as big as our own Milky Way. And so this kind of settled it that Curtis was right, based on Slipher's work, that these spiral nebulae were actually things that were outside of our own galaxy, and in fact not just outside our own galaxy, they were in fact galaxies in their own right. And at this point, that's when the term galaxy came to be defining as something separate from universe. At one point, the galaxy was considered to be the entire universe. So Edwin Hubble shows that Curtis was in fact right, and so we finally had proof that the Milky Way is not the only structure of its sort in the universe. So this totally changed our understanding of the entire universe, because they realized that some of these things were very small and dim, which meant they were very, very far away. And so suddenly, in just a couple decades, the universe went from being something just a few thousand light years across to realizing we were seeing things that were millions or tens of millions of light years away. But next, we want to discuss about the galaxies themselves and the different kinds of galaxies. Because if Hubble had stopped with just discovering what the galaxies were island universes, it would have made him famous. But he went a couple steps further and did other things that made him even more famous. So that's our next topic, is how galaxies are classified.